Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. Cloud-native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. We're proud to announce CISO Stories, a new podcast series in partnership with Cybersecurity Collaborative and CyberITL. CISO Stories features the candid perspectives and experiences of frontline senior security executives and dives deep into timely security topics. CISO Stories is hosted by Todd Fitzgerald, VP of Cybersecurity Strategy at Cybersecurity Collaborative, and Sam Curry, Chief Product and Security Officer at CyberITL. Listen weekly as they speak with extraordinary CISOs by visiting securityweekly.com/CSP.
Welcome back to Act 2 of Application Security Weekly. Is it a comedy or tragedy? We'll leave that up to you to decide. I'm your host, Mike Shima, joined by two gentlemen, Adrian Sanabria and John Kinsella. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We review suggestions monthly and we'll reach out to you once reviewed. Our next live webcast will be on March 18th at 11 a.m. Eastern, where you will learn how to prepare Linux hosts for unexpected threats. Check out our chat with Brandon in episode 140 to get a sneak peek at the topic. And visit securityweekly.com/webcasts to register now. And if you missed any of our previously recorded webcasts or our technical trainings, they're available for your viewing pleasure at securityweekly.com/on-demand. Oh, and my two gentlemen, I have to get a pun in here to see if I can make John grow. Two gentlemen of Vulnerona, for you Shakespeare fans out there. There's been some news in regular expressions and flaws. And here is a great article that at first I thought was going to be regular expression DOSes. We heard about these 15 or so years ago. I thought this was going to be more of just a refresher about what they are, and those are the days of when they could have found them, but they are few and far between. But lo and behold, here is a tool that went out and found some basically poorly crafted regular expressions that could be blow up in algorithmic complexity. And John, I think this one caught your eye in particular. Want to tell us more about it?
Yeah, I think it caught a lot of our eyes, but I got it in first. Haha. This is a fun one because it's a combination both, talking through a security issue, which we like posts here with a bit of meat and talk through the details. And it also satisfies my visual self in how it actually explains how regular expressions work. And I actually come with a prop this time. For those on the audio, you're not going to be able to see it, but I've got a copy of O'Reilly's Regular Expressions, Mastering Regular Expressions, all 315 pages of this lovely tome. Point being, as Mike, you're just saying, this has been around for forever, this stuff, but it can be super complex. And as again, we've said with all sorts of things here on the show, once you get that complexity into something, how do you make it secure and simple? And in this case, it's not so much, we're not talking about SQL injection or things like that, but still just denial of service, which, is what we find, or what I find frequently, the places where you want to use a regex, you care about speed because you're not doing it at once, right? You're doing it probably millions of times. So if someone's able to give you a pattern or a string in there that's going to kill it or DOS it, that's not a good thing. But the takeaway, what I like from this article, was the down towards the bottom, they start talking about non-deterministic alternatives, DFAs, deterministic finite automations. Yeah. And long story short, it seems frequently like a regex is the right thing to use, but there's usually either just something as simple as split or some other tools out there which give you linear time, are a lot less complex, easier to compile, quicker to use, and it's something good to keep in mind. So that's my summation of this.
No, yeah, great summation. I think I'll just to expand a little bit onto just regular expression recommendations is that I do love using them, but always make sure to anchor your patterns to the beginning and end of the line and pay attention when it's a single line or a multi-line flag, because those are two, if we're talking about common pitfalls or ways that regexes can go wrong, those are definitely two others that I've seen quite commonly. So kudos to this tool for grabbing at least a dozen CVEs over the past year, and looking forward to seeing more of it. Switching now to seeing possibly less of particular kinds of vulns is F5 ran into some issues with basically the two words that are pretty scary to see in the modern application security realm, which is unauthenticated RCE. So not very good there. But I wanted to pull this one out less because of F5 or what the specific vuln was, but more to talk about what they missed, or possibly, as many people are pointing out, apparently this was compiled without stack protections or without ASLR being enabled, things like that should have made exploitation a lot more difficult. The vuln might still have existed, but the vuln, as impactful as it could have been, might have been less. And I added into the show notes some links to some Project Zero write-ups as well that were just some nice pseudocode and examples of just where this, the F5 was falling against very simple problems. One was vulnerable to a simple stack-based overflow due to an integer underflow in his size calculation. That was one quote. And the other one was a flaw due to happily converting uninitialized stack memory into a printable IPv6 hostname. So size calculations, IPv6 host names, two very common, very known ways, at least how we should be handling such things. And yet here it goes sideways, and we get some eventually unauth'd RCEs due to these types of flaws.
I was going to make a joke about it being a good thing that nobody's using IPv6, but big IPs are typically exposed to the internet, and that's where we see a lot of IPv6 use is across the public internet. So, yeah, even worse than unauthenticated RCE is also on a product that's often exposed to the public internet.
And that's a great point. And we've seen 2020 was, I think, quite a year of different VPNs being targeted and exploited. And what other place than the externally facing do you need to put your VPN? So you're bringing in an attack surface right there. And hence, one of the other things that I put into the show notes related to this was calling out to the CyberITL. It's a project that we've mentioned maybe once or twice in the past couple of a year or so. But it's basically pointing. The reason I brought it out is that it has a methodology on what they call, safe compiler settings or safe configure or safe compilation for software, and it's going through a whole bunch of basically turn this on in your compiler, let the compiler take care of some basics of baseline security, and then go on and take care of your regular expression problems and other things that compiler settings aren't going to save you with. So lots of reading for today between books and a bunch of extra links. Other reading for the day is also in about why even Mallory still love Android. And this was a paper about revisiting TLS security in Android. The reason this stood out to me is not too specifically about Android, because there's only so much you can beat a dead horse in the sense of an ecosystem that's a bit tougher in terms of how do you get everybody patched up to the same level, but sort of a lesson in the sense of here is an approach that Google took, Google Play, that says we're going to have a baseline configuration about how to do your TLS more secure. But what these researchers found were that a lot of people are actually making their setups, making their TLS configurations possibly even less secure than they should have been or could have been, exposing themselves to intermediation attacks. So it's sort of that universal observation on what the difference between mandating a security control, meaning, go configure everything properly, versus did you actually do anything provide anything from an automated perspective that actually makes this easier to do? This is a little bit of a callback to our previous segment.
Yeah, I think one of the most painful things with both these last two stories is, stuff where we know better, but we don't do it. We don't take the security advice that's already out there. And, especially in things, like talking about how you're compiling code, like that shouldn't be a conscious decision. That should just be, in the configuration of everything that you're doing, set at a higher level so you don't have to think about doing the correct security thing.
Yeah, and to me, it's sort of like you're picking out the idea that these are things we should already know and do. There's another article about Post-Spectre Web that, again, I've tried to clump a bunch of different links within this particular note about these are things that we maybe don't know as much of how we should be doing things here, protect ourselves. So there is a blog post from Google Security that they were showing some of their researchers were showing different ways of exploiting Spectre through pure JavaScript. So that should be somewhat worrisome. I linked to another some research coming out of Usenix that'll be appearing later this year about side channel attacks coming straight out of JavaScript inside the browser. So the attack side of things are definitely being explored. The attacks are getting better. And on the defense side of things, this link from WC3 about the Post-Spectre Web development essentially boils down to try not to let the attacker run their code within the same process that your domain is sitting in, which is a little bit tough. And that's where, if we're going to throw out the idea of that shared responsibility, there's a bit of a shared responsibility between browsers to do some process isolation, as well as websites to adopt some of the security-minded headers that are listed in this W3C article.
There's a section which I sort of like at the bottom of the first chapter, to call it, right? They've got a little TLDR in there, sort of lists through 5 ways to sort of how do you actually some general guidance on how to minimize this type of things, which I liked. It's it's funny actually. I'm not sure when W3C switched over to GitHub, that sort of caught my eye in the URL. So that out of the way. That's sort of interesting, right? I mean, they've been on their own and independent doing their own website for ages, so that's an interesting move to me, but not AppSec. On the AppSec side, it's interesting to see, thinking about this from a browser point of view, and we've talked about this before, but I like that they threw that little, and I think they're pretty good about this in general, but here's 5 things for you to focus on. They'd probably put that at the top, but say, Libby.
Yeah, when Spectre came out, the idea of it being exploitable in JavaScript made it really scary. But if you couldn't exploit it in JavaScript, all of a sudden it became a lot less scary because you had to get code on the host somehow. You had to run locally, and I had my opinions. I felt like the response did more damage than the actual bug was capable of causing, but now with a proof of concept, with a JavaScript proof of concept, I think people are going to have to come back and revisit how they look at some of the side channel stuff and how they're mitigating it, like their threat models, everything.
Yeah, and I think the one of the things, it's always to make sure we position this and say when big research articles start out with once an attacker has unprivileged code execution on the system, that's a big step right there. It's still important to consider, but it's sort of that issue. I've seen bug bounty reports in the past that have also started with assume the same origin policy is broken or something like that. So we have to be careful about what assumptions are in these threat models to make sure that we're approaching this with a right risk-minded mentality to it. But of the list that John was pointing out, one of the things that I really liked about this TLDR list in the W3C article is that I think, and here I do have my fingers crossed, that a lot of these headers are actually relatively easy and straightforward to deploy, much more so than content security policy ever was. So talking about like a cross-origin policy, cross-origin opener policy, things like that. These are things that are either going to that aren't just going to break your application in subtle and weird ways. They're a lot easier to test, and they're a lot easier to reason through. So kudos to that for seeing those as actually, I think, much more viable paths forward for developers to adopt.
And that's sort of the thing about this, right? Is if this stuff isn't easy to adopt, I mean, I forgot the name of what you just mentioned, because I mean, I remember when it came out, but we looked at it and like, I'm not going to use that. And it's so, yeah, that's, I mean, especially for this, right? Because the folks that are working on this type of thing are usually, at least my experience, the web developers, sort of more front end guys. And nothing against that group of folks, wonderful people, but I usually think of, if there's security people in a company, AppSec people in a company, they're usually more back-end focused than they are front-end. I don't know if you guys would agree with that, but so we have to make this stuff easy for those guys to be able to consume and use and appreciate.
I noticed at the bottom, they've got this tip, and they mentioned that they've created a Chrome extension that helps you analyze your website and whether or not you need to do some mitigation, called spectroscope.
Yes, which is also, we need good naming for things, of course. I love a good name for vuln or tools. But I think that's John's making a great point, is that a lot of times if we, talking about the general we of the application security industry, are talking about the front end vulnerabilities such as CSRF or cross-site scripting, that's usually, well, look how the content is being rendered, or make sure your framework has tokens. But that is really different from figuring out what are all the origins that where these resources are coming from that make CSP level 1, 2, or 3 viable and deployable. And that is just something that I've seen some tools, even some Chrome extensions or browser extensions to help with configuring CSP, but nothing that's been so successful or straightforward. So it is great to see more extensions to come out to help front end developers understand, am I exposed, or how exposed, or give me something as a concrete action to take in response to this, rather than, oh, cool, I read an article, now I'm pretty worried. I don't have anything to do about it, so we'll just move on to the next problem that we see. And sort of moving on to next problems, I pulled out an article here from about the Linux Foundation. They're debuting SigStore to essentially sign the software artifacts that get built out of, obviously from their perspective, open source tools, open source projects, but the principle could be adopted to anything. And this is along the theme of course, 2021 is the year of supply chain. Thank you to SolarWinds for putting that back onto everyone's mind. But we've also, John and I, we've touched on this in a couple articles talking about reproducible builds as well. And I guess one of the things here is that I absolutely don't want to be negative about this type of approach of signing, but signing is just one step towards this supply chain, meaning we'll now get a good sense of the provenance of what this software that we're running on our container, our operating system, et cetera, what have you, but we still don't have a good idea perhaps of that bill of materials, or what were the security steps that went into hardening this. Something as simple as call back to the F5 scenario. Did they turn on the recommended compiler settings to make this, a hardened binary? So there's still a lot of work to do, and I'm mostly saying this to make sure we have a broad threat model of what we're considering, and we don't over-index on what this is actually protecting us from. It's just one tool that's necessary but not sufficient.
Yeah, it's interesting, and again, we've talked about this a bunch. It's interesting how a lot of folks I know have become very interested in this in a sudden, and it's, at least for me personally, I don't quite get what's, to use the phrase, what's sexy about it. I'm glad it's happening. It makes a ton of sense to me. It is, as you were saying, to use the phrase from earlier, it's layering security, right? I've been lucky. I've seen this talk given twice now, from Luke Hines. Well, one's from Luke, and I think one's from one of the other guys on CNCF SIGs. So I've got to see them actually do even a demo of it. So it's sort of neat. It has its uses. I'm really curious to see how it's adopted. But yeah, right. It's I think it's one of the, and I think there's a few things going on in open source right now, and I think you're right, Mike, in that this is only a tiny piece of things. But from an open source point of view, I think one of the more important things there is what is the origin of that software or that software change. So I think in those environments, it's pretty good to know about this, especially, we've been talking recently about, typo squatting on package names and stuff like that. So I think the more we can do in the open source side to try and provide trust, I think it's sort of worthwhile there.
Yeah, I think. Oh, go ahead, Adrian.
I can see this. This is something you have to be careful with too, because we've actually seen quite a few attacks where signing keys are targeted. And if they're not well protected, this is only going to be as trustworthy as those signing keys. And the protection of those signing keys is for this stuff. So you got to be really careful there. It goes south pretty quick.
It's and what's interesting about that you mentioned it. I'm trying to mute both of my systems. The demo that they do, they actually have the signing key in the repo. So the point there that they're making is like, obviously it now comes down to what your passphrase is in that key. But if you put the key into the repo along with everything you're trying to sign, you can do key rotation really easily just by a new git commit and then sign that and keep going. But really what they're looking at is more about providing a transaction log in a public space, in a peer-to-peer space, so you're able to actually see what was signed and when, and sort of provide transparency to it from that point of view. We're going to have one of the guys from Linux Foundation on in, I think, 2 weeks. So I suspect we'll be talking a little more about this again then.
Yeah, be good protection against, I don't know if typo squatting in repos is still a thing, but yeah. Yeah, you see that. I mean, it's such a common fraud technique. I can't tell you. This is kind of related. I can't tell you how many times I order something from Amazon, and I think I'm getting it from one store, from one seller, and a month goes by, and I'm like, what happened to that? And it eventually shows up with, having shipped straight from China or something like that, with a bunch of, it just sat at customs for a while. It's got all these custom stamps and stuff like that on it. Now I have to be really careful looking at what I'm ordering and where it's coming from. So yeah, understanding that origin is, I think, will help some things.
Attack the humans. So we're prone to typos. We're prone to misspeaking, as anybody can listen to many of the past episodes as I stumble over words, and we're prone to compromise if for moving a lot of the security attack surface out to the keys and the holders of those keys. So always great ways to revisit our threat models as we're talking through these things. Another thing that I wanted to highlight, sort of talking about threat models, or maybe talking about the teams that are doing the threat models, is I did pull out one last article from CISO Online that normally this is a type of article I would avoid. It's called 8 new roles for today's security teams, and I just avoid lists in general. They tend to be boring or just clickbaity, or just you have to click through 8 different pages because they want to serve a bunch of ads. In this case, what stood out to me is what the roles were and what that kind of means or perhaps implies about where security teams are going. So a quick refresher, some of the roles that stood out to me were an IAM engineer, somebody doing third-party risk. So there's your vendors, there's your supply chain, you're looking at your SigStore signing, DevOps security engineer, probably not too surprising to listeners here, but also a cloud security architect. And I thought just seeing those roles falling underneath the security team umbrella, I thought was kind of a good trend and a good sign that is implying that security is taking on a lot of that responsibility of development, rather than just saying, DevOps, you have our responsibility for security, you just do all the things we say, we'll give you a bunch of tools, and we're going to walk away. This is possibly saying security is like, maybe we will actually do some engineering ourselves, and we'll join you in that development, and we'll bring you some security-minded solutions for you to help out with this cloud environment. So I'm not sure if you both are now updating your resumes and your LinkedIn profiles as we speak to match this, or if there was something else that maybe stood out about this article for you.
It's always interesting to see how these roles are changing. Like, I remember the first time I saw chaos engineer, a job posting for chaos engineer. I was like, what?
That's something I can help with.
I think another thing to me is what stood out perhaps was also what wasn't listed, in the sense of we didn't see an explicit AppSec engineer or someone who's running the AppSec tools, whether it's the SAST or DAST tool or something like that. So it was also perhaps nice and refreshing to see a move away just from sort of a tool-oriented or very task-oriented type of security role into this idea of building and engineering. So I think that's the other reason I kind of like this, and we just sort of recommend it as an idea of, if you're building up a security organizations, trying to think about where to invest, how to grow it, maybe this is a little bit of a guideline for where you want to take that direction of the team.
Yeah, the only ones I see here that really strike me as new is, I don't recall ever seeing an IAM engineer, identity and access management engineer, or a manager of third-party risk. So those seem kind of new. And then DevSecOps security engineer, threat hunter, like vulnerability risk analyst. These are all things that we've been doing for decades that, maybe we're doing it in a new place with a new focus, or we've got a new name for it. Like threat hunter, we just called security analyst back in the day. So yeah, it's got a nice shiny new title, but I'm not sure all these are new. Like the article suggests, CISO's not new. Incident response manager isn't new. Cloud security architect, that I actually started out as a security architect. And sure, you can always tag qualifiers on here like cloud, but.
Yeah, I think there's, to me, you point, I skipped over the IR and the vuln risk analyst, because those are the dustier named roles, so to speak. But those are also the kind of the operation focused ones. So I guess, if I were to also highlight why this stood out, is that it was a good mix of operations and engineering. So hopefully that's where the trend goes. And CISOs just want to get a mention in there. It's so that's not necessarily a new role at all. But I will guess maybe perhaps it might be new in the sense of, is it a CISO overseeing an engineering team, sort of more of a VP of engineering type of approach, or more of kind of a policy and compliance type of approach?
What I'd love to see are the new skills that these roles need. I think that's the interesting article that somebody needs to write.
Well, guess what, Adrian? We're at the end of the news segment, which leaves us time to watch you go and write up a list of new skills that these teams need to do. I usually try to sign off this by assigning homework. John, you're off the hook this time. You already did your book reading with the Regex, so thank you. So that's up to you, Adrian. But yes, joking aside, I want to say thank you, Adrian. Thank you, John, for joining us. Thanks, everyone, for listening. I have to close this out with my favorite stage direction of all time. It's time to exit. Stage left, I believe, chased by a bear. We'll see you next week on Application Security Weekly.